Here we're looking at systems of equations. So you have a solution to a system if that solution, a point, makes both equations true. So let's check that out here. So we're going to see if this is true. So 8 for the first one times 7 for x plus 5 in that first equation times 8 for y is supposed to equal 96. Okay, so we're plugging in this x value and this y value into that first equation. 8 times 7 on a good day is 56, and 5 times 8 is 40, and 56 and 40 is 96. So yes, it does make the first equation true. So now we'll check the second equation, so this one here. So that gives negative 6 times 7 minus 5 times 8 is supposed to equal, we'll find out, negative 82. So let's see, 6 times 7, that would be negative 42 minus 40, negative, subtract a number, so it's negative plus a negative is, yep, negative 82, check. So this right here, 7, 8, is a solution to both equations, so it's a solution to the whole system of equations. And after we solve a system in various ways, we do want to plug back into both equations and check. So let's try solving some systems. This one we're asked to solve by graphing, and I'm going to use the point-slope method. So we'll graph this one first. Y-intercept is y equals 1, x equals 0. And then the slope says negative 2, so that would be negative 2 over 1. So drop 2, run 1, drop 2, run 1. We can go the other way. Up to left 1, up to left 1. So graphing that. Oops. Something like that. And the other one, let's graph that in red. So this equation says to start at negative 4 and then go up 1 over 2. And bang, looks like there's my solution. So draw that line. All right, so I think the solution here is positive 2, negative 3. So we want to check that out now. So solution 2, negative 3. So let's plug back in to make sure. So y is negative 3, and that's supposed to equal negative 2 times 2 plus 1. That's negative 4 plus 1. Yep, that's negative 3. The other equation, y is still negative 3. 1/2 times 2 minus 4. Half of 2 is 1. Minus 4 is negative 3. Yep, it checks. We definitely have a solution to the system. And sometimes solutions you can graph and see it, but other times the numbers aren't so nice. So we need other methods, like the substitution method. In this one here, we're told y is equal to this whole thing. So that means anywhere we see a y, we can substitute this expression in for it. So here, let's rewrite the first equation. X minus 3 parentheses equals negative 13. And then we can substitute in our 4x plus 8. So we'll have to do a distribution here. That negative 3 needs to be multiplied through. So we'll have x minus 12x minus 24 equals negative 13. Like terms here, negative 11x minus 24 equals negative 13. And then we'll add 24 to each side. So 24 minus 13 is 11. Well, isn't that nice? So if negative 11x equals 11, divide by negative 11, x equals negative 1. Coming back to this second equation, that's going to tell me y. So 4 times negative 1 plus 8 would give me negative 4 plus 8, or a positive 4. So we think the solution is negative 1, 4. To check that, we'll plug into the other equation. So let's see, negative 1 minus 3 times 4 is supposed to be negative 13. So negative 1 minus 12, yep, negative 13. We got ourselves a solution. All right, let's try one more. Here we're going to use what's called the elimination method. With the elimination method, we want to try to line up a pair of variables to be opposites. So 3 versus 4. How about here? If that was a positive 2x there, that would work. Or, actually, this is a good idea. Each of these terms is even, so I could take this as second equation. That's what I'm going to do here. I'm going to take the second equation and multiply by negative 1/2, which is like dividing by 2. And I have to do that to each term. So that's going to give me a new second equation. Negative 1/2 times negative 2 is going to give me 1x. And then here, negative 1/2 times positive 4 is going to give me a negative 2y. And then half of 22, make it negative, is 11. And then the other is negative x, so we stack them, plus 3y equals 15. Then we just add these coming down. So negative x plus x, that zeroes out. 3 minus 2 is going to be 1y. And then 15 minus 11 would be 4. So it looks like y equals 4. Plugging that into, say, the first equation, negative x plus 3 times 4 equals 15. So opposite of x plus 12 is 15. Subtract 12, and we get the opposite of x is 3. So x would be negative 3. So I think I have a solution. I think the solution is negative 3, positive 4. And I found the second value from the first equation, so now I'm going to check with that second equation to make sure it actually works. Make sure I got red here. So negative 2, plug in x, negative 3. So this is my check. Plus 4 times 4. We'll see if that equals 22, question mark. Negative times a negative is a positive. Plus 16, 16 and 6 is 22. We got ourselves a solution. Not too bad. Hope you found this useful. Take care. Do good math.